Hello students, I hope you are good, well and fine, and today we will be continuing our lecture on exercise on the topic surface area and volume. So as we discussed already various problems on surface area and its and the volume for the solid figures, and we came across various formulas for cuboid, cylinder, cube, sphere. The cuboid, in the case of cuboid, we learned about the total surface area, the lateral surface area or the volume, and same goes for the cube, and for cylinder the curved surface area, the volume, and etc. So we saw that how the formula applied in various questions. Let's dive deep into those concepts and see more example. As you go through more examples, you will challenge yourself or the concept, how much you gain from the theory part of this surface area and volume. So let's begin with our first question. Let's see. Our first question says, if a chord in the form of square, okay, a chord in the form of a square encloses the area S. So area of a chord which is in form of a square. Okay, so here is my chord. This is my chord in form of square with side equal to x. Say x is its side. Now this also x, this is also x, this is also x, because it is a square. In a square, all of the sides are equal to each other, and we know the area of a square is equals to side whole square, which here it is x square. I hope this is clear. Now the same chord is bent. Now this chord is now bent in the form of a circle. So first of all, let's see how long is this chord. If I am standing here, I covered the distance of x, then I covered again the distance of x. In total I am covering 4 times x. So a total length of the chord is equals to 4x. So, and from this I know that this chord now bent into the form of circle. So the circle, my new figure will look like a circle, and this circle circumference will equals to this 4x, because the length of the chord is 4x. So does the circumference of the circle. Now we know the formula for the circle. Circumference of the circle, which is equals to 2 pi r, which is equals to 4x. Here, from here we know r is equals to what? R is equals to 4x by 2 pi. Now 2x by pi. So from here we found out the radius of the circle formed by the chord. Okay, now the actual question was the find out the area of the circle. So area for the circle, area for the circle is equals to pi r square, and we know what is our r. R is equals to 2x by pi. So 2x by pi whole square, which is pi times 2 times it is 2x times 2x pi times pi, 1 pi get cancelled, this get cancelled. So now my simplified uh, expression will look like this, which is 4x square by pi, and I know what I know, that the area of a square is equals to x square, and I know s was my area of the square as it is given here. So s is equals to area of a square, which is x square. That means the area for the circle, area for the circle is equals to 4s by pi. I hope this is clear. So my answer for this is 4s by pi. This option is correct. So let's move to next. Now here in this question, if L, B, H of a cuboid are increased, decreased, and again increased by 1%, 3%, 2% respectively, then the volume of the cuboid we have to find out. Okay, so here let's make a cuboid. So my cuboid will look like this, like this cuboid or box, you can say. This is my cuboid. Okay, with length, length is my this L, breadth is my this B, and height is my this, which is H. I hope this is clear. And we know the formula for the volume of a cuboid is equals to L times B times H, or the simplified version LBH. I hope this is clear. Now after a 1% increase in length and 3% decrease in width, okay, so let me use the respective color. So 1% increment in length, here 3% decrement in breadth, and 2% increment in height. So my new dimensions new dimension is so my new dimension is new length L is equal to the because there is 1% increment, so L plus the 1% of L is equals to 1% of L is equals to 1 by 100 L. I hope this is clear. Okay, so this is 101 L by 100. Now new breadth, which is capital B, is equals to the previous minus, because the breadth decreased, so that's why we are subtracting. So by how much? By 3%. So 3% means this. Okay, I hope this is also clear. So this means 97 B by 100. Now new height, which is capital H, is now height get increased, so H plus increased by 2%, so the 2% is this. So this is my 102 H by 100. Now my new dimension are as follows. the length is this, breadth is this, and the height is this, and multiplying all of these dimension will get my volume. So a volume is equals to, so new volume is equals to 101 times L. Let me write it like this: 102 LBH by 10 100000. I hope this is clear to you. So by solving it you will get your answer. Okay, so I hope the calculation you can easily do. So just do the calculation work, that's it. Okay, so according to this you will find out that this the new volume is decreased, or the new volume is less than the previous volume. I hope this is clear to you. Now let's see next. In this question, the radius and height. Okay, so the radius and the height of a cone are each increased by 20%. So this is my old cone with radius r and height h. The after increment in radius and height, the cone will look like this, something like this. It get bigger. Now my radius is, the new radius is the radius increased by 20%. So my new radius will be r plus 20% of r, which is this. I hope this is clear. That means 120 r by 100, or I can even write it in simplified fraction, which is this, or more even simplified fraction, which is equals to let me write down. So 12 by 10 r, which is equals to the 6 by 5 r. Okay, I hope this is clear. I just took common 2 from both of the terms, numerator and the denominator, and we lived with, in the numerator it is 6 and in denominator it is a 5. So new radius is my 6 by 5 r, and the new height will be doing the same calculation, it also increased, so h plus increased by 20%. So this means the 20% increment is 20 by 100 h, and this will give me the same fraction as like this. Okay, so the new height is my 6 by 5 h. I hope this is clear to you. Then the volume of the cone is increased by, so we have to find out the volume of the cone is increased by. So here the volume of the cone, if you recall, the volume formula for the cone is just the 1/3 of the volume of the cylinder. So volume of the cylinder is pi r square h. I hope this is clear. And here the volume is 1/3 pi, the radius square, radius is 6 by 5 r whole square, and the height is 6 by 5 h. By simplifying it we will get 1/3, 6 times 6 times 6 by 5 times 5 times 5 r square h. I hope this is clear to you. Now we have to find out the volume of the cone is increased by. So just subtract the value, this value from this new volume. So by subtracting, let me use blackboard. So the new volume is 1/3 pi r square h, 6 cube 5 cube. So 1 by 3 pi is there, so pi r square h, 6 cube by 5 cube, and the old volume is 1 by 3. The old volume is 1 by 3 pi r square h. So taking 1 by 3 pi r square by h common, so this is my 6 cube is 216, I think. So let's see. 6 times 6 is 36, and 6 times 36 is this 6 3 18 18 19 20 21. So yes, it is 216 by 5 cube is let's see what is 5 cube. So 5 times 5 is 25. 25 times 5, let's see, it is 2 here, 10 and 12. So 1 2 5. Okay, so I hope this is clear. Now the here it is minus, so just evaluating this, I will left with a minus 1 to 5, which is 1 3 pi r square h. So 216 1 to 5 here, 1 11 2 is 9, so it is 91 by 1 to 5. So this volume is increased by that much of. So what was our unit? I think whatever the unit, let's say the centimeter. So this much of centimeter cube of volume is increased. So in term of say in term of percentage, we know that 1 by 3 pi r square h claims the 100%. Yes, because this is the old volume and it is itself 100%, and we increase this much of volume. So to find how much of this is in term of percentage, just multiply this by just multiply 91 by 1 to 5. Okay, so 1 pi r square, so this means 91 1 to 5 times 100 percentage. So just you can easily find out. So let me do it. So this is 5 cube, this is 5 25 times 4. Okay, 25 times 4, which means 5 square, which means I can eliminate this. So 91 times 4 is 4, and just 36 divided by 5 is 7. 35 2, which is 10, and 4, which is point something 8. So 72.8 is 72.8 percentage. So my answer will be 72.8 percentage of increment happened. Okay, so let's see. So the option D is clear. So option D is the correct option. I hope this is clear. So yes, indeed the option D is my right correct option. Now in this question, question says that there is a cylinder circumscribing the hemisphere such that their bases are common. Bases are common, that means this is my cylinder. Let's see. So this is my cylinder. Okay, I hope it is clear to you. This is my cylinder with this radius, say r is my radius. Okay, and in it there is a hemisphere like this. Hemisphere means the half part of a sphere, or if a ball divided into two equal parts going through the center. So this will create a hemisphere like this. Okay, I hope you can easily visualize what is hemisphere, or how you can easily make a illustration if you recall how the half cut ball looks like. Okay, so this is my hemisphere. Hemi means half. Hemi means half. Hemisphere. So hemisphere, half sphere. Okay, so this means this is my R, because in a circle, sorry, in a sphere, from the point of center to any point on the circumference or the surface of the here in this case sphere, the surface, any point on the surface and the point in the center, the distance remains the constant, which is r. And we know that this is the base is common to the cylinder and for the hemisphere, that means this is also r. So if you see that the hemisphere having radius r, as well as the cylinder length is also r, and the cylinder radius is also r, the all things remains equal to each other. I hope all the things are clear to you. Now in this case, if you see the volume of the cylinder, we know is pi r square h, and we know h is our equals to r in this case. So pi r square times r, which is r cube. r cube. And we know a volume, here is the volume of cylinder, and volume of the hemisphere, volume of hemisphere is equals to the half of the volume of sphere. Volume of sphere is what we know, the volume of sphere is equals to 4 pi r cube by 3. And by doing some calculations, the 4 get cancelled and get 2 over here. Okay, because of the half term. Okay, so now applying the values, respective values we get. So so now what we will do, we will find the ratio of their volumes. So ratio of their volumes is just taking ratio with respect to hemisphere, then hemisphere, then the cylinder. Okay, so which is 2 by 3 pi r cube by pi r, here is cube cube. So this pi and r cube term get cancelled, we are only left with 2 by 3. That means the ratio is 2:3. Okay, I hope this is clear. Okay, so ratio is 2:3. So the option C is our correct option. So I hope you find finding these problems intriguing and interesting. Okay, and these problems will challenge your concept. And let's see the next problem. Indeed, the answer C was our correct answer. Let's see the next problem. Here, this is a very interesting problem. This asks, first of all, understood the question. So we have a hollow cylinder, say a cylinder. So this is my hollow cylinder will look like. Okay, because it is hollow, and viewing on top, from the top view, this is my outer cylinder and this is my inner cylinder. Okay, and we know the wall with T thickness, so this thickness is T, and the inner radius is r, that means this length is r, and the length of the cylinder, the whole length is L. I hope this is clear. So finding the required volume, so the volume we are asking about is this part volume. So this part, the if you subtract the volume of the bigger cylinder or the blue cylinder to the volume of the inner cylinder, we will left with the volume of this part, or if you visualize of this part. I hope you are visualizing what I am saying. Okay, so let's do that right away. So first of all, find out the bigger cylinder volume, that is, and we know the radius for the bigger is this, which is r plus t. So the bigger cylinder volume, or the volume for the blue cylinder, which is equals to, we know the volume of the cylinder is equals to pi radius square times h. We know the radius is r plus t square and the height is L. So this is my bigger cylinder volume. Now the smaller cylinder volume, or the red cylinder volume, smaller, or the inner cylinder volume is equals to pi, its radius is just a small r, so pi r square h. H is my L. In both the cases, because the height of the cylinder remains the same in both of the cases. So it is this. By just now subtracting each other, now subtracting smaller, subtracting smaller volume by bigger, smaller volume from bigger volume, that is equals to the pi r plus t whole square L minus pi r square L. I hope this is clear to you. Okay, so now taking things common, we would have pi L r common, so we are left with pi r plus t whole square and minus r square, that means pi L, so a square plus b square plus 2ab minus r square. The r square term get cancelled, so we are left with just this thing. Taking 2rt common, we will left with taking 2rt. 2rt over here, this will have 1 and this will be what? This will be t by 2r. So this option B, the option B is my correct option. So for the volume of the required part, or this part, the in between part, we have the volume equals to this 2 pi r lt times t by 2r plus 1. I hope this is also clear to you. So let's see, are the answer? Yes, indeed the answer, the option B is our correct option. So I hope you find those problems very interesting and very challenging, and you solved with me with great interest, and you learned new things. I hope you time to time you recalled the formulas. As you memorize them, you will find that problem solving will be very easy task for you. So thank you For now, let's meet again another time. Thank you.